Hey guys, Mr. Milton here. Today we're going to talk about similarity in right triangles. This will be the first day of 2 lessons here. At the end of this video you should be able to simplify radicals and use the skill with the Pythagorean theorem. You should be able to explain the difference, explain what a geometric mean is and to find the geometric mean of two numbers. And you should be able to separate a right triangle into 3 similar right triangles and match up the corresponding parts. Okay, so first things first, we are going to review simplifying radicals. We'll need this as we go through this section. Remember, simplifying radicals, you can do the factor tree. That's the form that I'm most familiar with. I think most people are. And what you want to do is just go through and break down this number into 2 numbers that multiply it. Only rule is that you cannot use one. So every step should just basically be a multiplication problem of the number above it. So 147, it's an odd number. Checked, I think 3 goes into it 49 times. Okay. 3 is prime, so I'll circle that so I know that that branch of the tree is dead. 7 goes into 49, so 773. So here's my factorization. I have 7 times 3. For my radical, to simplify, I take out my pair of radicals, or my pair. That goes to the outside. The answer is 7 radical 3. Okay. We can do the same thing with 320. So 320, 32, and 10 jumps out at me. That is 16 and 2. 16 will break down to 4 and 4. I know that those are a pair, so I'm going to stop with that. 10 breaks down to 2 and 5. Okay, so now underneath my radical I have 5 times 4 times 4 times 2 times 2. I'm going to take my pairs, a pair of 2's, I have a pair of 4's, take those to the outside. So I have 4 on the outside, I have 2 on the outside, I have 5 left on the inside with no pair. And so radical 320 simplify will be 8 radical 5. Okay, there are different ways to get to that answer, but the answer will be the same no matter what. Alright, and then our final review here. We have 2 radical 6 squared. Remember that when you square a number, that means you're multiplying it by itself. So 2 radical 6 times 2 radical 6. And the rule for multiplying radicals is inside by inside, outside by outside. Okay, so that means that I'm going to multiply the outside numbers together. 2 times 2 is 4. And I'm going to multiply the insides together. Radical 6 times radical 6 is radical 36, or more easily 6. Okay, so 4 times 6 gives me 24. Alright, and so there we have it, reviewing simplifying radicals. Okay, so now we'll use that skill as we talk about Pythagorean theorem. Okay, remember the Pythagorean theorem is a squared plus b squared equals c squared. Okay, and where c is the hypotenuse, and a and b are the legs of the right triangle. Directions for this section say leave your answer in simplest radical form, so essentially remember what you did up here. Alright, and so it says find the missing side, so in this problem I'm just going to put an x here. Alright, and so basically for this problem we can just plug in the numbers into Pythagorean theorem. We can call 8a, so 8 squared plus 12 squared should equal x squared. 8 squared is 64. 12 squared is 144, and so x squared is 208. Adding those two together. And so now to find x, I just need to take the square root. I'm just going to divide by 2. Divide by 2. 57 prime. Nope, 3 goes there. So 1, 9. Okay. So 19 is prime. So I have my pair of 2's. So 2 on the outside. And I have 3 and 19. Don't break down any further. So 3 times 19 is 57. So x should be 2 radical 57. That's my answer in simplest radical form. Alright. Second problem, still Pythagorean theorem. It's right triangle, but this time we're given the hypotenuse, and so we're going to set this up. I can say s squared plus 6 squared equals 2 radical 21 squared. Okay, similar to what we did up here. Remember, that means we're doing 2 times 2, which is 4. Radical 21 times radical 21, which is just 21. So 4 times 21 is 84. 36 is 6 squared. We'll just keep s squared as s squared. Okay, and so now we're solving for s squared. I'm going to subtract 36 from both sides. S squared will equal 48. And so to find s, I'm going to take the square root. And what that will mean is I have 16 times 3, or 4 times 4. Okay. So my answer will be s equals 4 radical 3. Okay. So that is the review for the radicals. Okay, and we apply that to the Pythagorean theorem. And now we're going to get to the new stuff. Okay, the new stuff involves similarity in right triangles. Okay, all right, so first off, the geometric mean of two numbers is the average of the two numbers after you multiply them. Okay. To find the geometric mean, you need to set up a proportion. Okay, so and here's how this proportion will be set up. Typically, I'll set up a proportion. If we have two numbers, let's say we have the numbers a and b. In order to find their geometric mean, what we're going to do is we're going to set up this proportion of a over x, where x is the geometric mean, equals x over b. Okay, so if we have two numbers a and b, this is how our proportion is going to be set up. So let's put that into practice down here. If I want to find the geometric mean between the numbers 2 and 50, I'm going to set up this proportion. 2 over x equals x over 50. Okay, and so cross multiply. X squared equals 100. In order to find x, I'm going to take the square root, and x will be, you can say, plus or minus 10. Okay. Okay, in this sense, we'll keep plus or minus 10 because when we take the square root, remember there's a positive and a negative root. If we're actually finding the length of an object or any kind of measurement, remember that a negative number does not make sense in that case. Okay. All right. The same process here for the geometric mean of 5 and 15. Our proportion will be 5 over x equals x over 15. Cross multiply, we get x squared equals 75. Take the square root, it's 25 and 3. Okay, so then we find that x is plus or minus 5 radical 3. Okay, again, if we're ever finding the length or a measurement of a side, then the negative answer doesn't make sense. But if we're just finding the geometric mean, the number, then the negative answer does make sense. Okay? Alright, so that's geometric mean. Essentially, it's just another proportion that we can set up and solve. Okay? We'll work on the application on the back here. So we're going to one, I would think is one of the more difficult parts of this chapter, and that's similarity in right triangles. Okay? And so what we're going to do here, we're going to redraw and label the 3 right triangles from this diagram. Okay, notice that there are 3 right triangles in this diagram. First, the original one, the large one with sides A, B, and C, right triangle, 90-degree angle. There's a small one, okay, here. Sides aren't, I guess, oh yeah, they are, they're labeled. Sides A, H, and R. Notice that this is a right triangle because this has to be a 90-degree angle. Okay, and then there's a medium with sides H, S, and B. Again, this is a right triangle. Okay. Each triangle has 3 sides: a short leg, a long leg, and a hypotenuse. Okay, and so let's redraw these triangles and make sure that we set up and show why they are similar. So I have my small one. I'm going to set it up how it is labeled, or how it's originally set up. Okay, so I have a right angle here. My hypotenuse is A. My long leg is H. My short leg is R. Okay, and long leg and short leg might be a little bit difficult to tell all the time, but in this case, it's a little bit easier visually. Okay. My medium triangle, it's just the half one. I'm going to draw it how it's set up. Okay, I have a short leg of H, I have a long leg of S, and I have a hypotenuse of B. Okay, and finding the hypotenuse is pretty simple because remember the 90-degree angle will always be pointing to it. And then I have my original triangle, the large one. Looks like this. Okay, I have sides A, B, and C. A is the short, B is the long, C is the hypotenuse. Okay, and so we're going to make sure that we label all these hypotenuse, long, short. Hypotenuse, long, short. Hypotenuse, long, short. Okay, so we've already kind of talked about these a little bit. All right, before we go forward, I want to explain why these triangles are similar. Okay, I've already said that they are similar, and you've already seen one angle in all of them, that they're all 90-degree or right triangles. Okay, they all have that right triangle. But then notice that our small triangle has this angle in it. Okay, that's the same angle as our large triangle. So by angle-angle similarity, these two have to be similar to each other. Our medium triangle has this angle in it. So by angle-angle similarity, these two triangles have to be similar to each other. And if this triangle, the small triangle, is similar to the large triangle, and the medium triangle is similar to the large triangle, then by the transitive property, the small triangle has to be similar to the large triangle. The small triangle has to be similar to the medium triangle. So all 3 of these triangles are similar to each other. Okay, and that happens if we have an altitude drawn from the right angle in a triangle. Okay. All right. So diving into this a little bit further here, it says now use your redrawn triangles to find the missing side in each proportion. So here we have it. They say R over H. So if we look at what triangle they're talking about the small triangle. We've got short over long. I'll just use one letter from here on out. Equals something over S. Now, the way that these proportions are set up, we're looking for a triangle where S is the long side. Okay, and that's the medium triangle. S is the long side in the medium triangle. And now we're going to look for the short side in the medium triangle. The short side in the medium triangle is H. So that's H. All right. second proportion, it says r over a. So what triangle has both r and a in it? The small one. R in this case was short, and a was the hypotenuse. So I'm going to look for a triangle where a is the short side, because that's what they gave me. No, this is short over hypotenuse. So in the triangle where a is the short side, what's the hypotenuse? C. Because that's the original triangle. Okay. In problem 3, they gave us b over c. That's the proportion they have, or the fraction they have set up. B over c. What triangle has b and c? The large one. And in the large one, b is the long, and c is the hypotenuse. So that should be the same as long over hypotenuse. So which triangle has s as the long side? The medium. What's the hypotenuse in that one? B. And then finally, number 4, we have b over h. What triangle has b and h there? That's the medium, where b is the hypotenuse, and h is the short side. So now I'm going to look for the triangle where a is the hypotenuse, it's the small one, and what's the short side? R. So my answer is R here. Okay, so now this is just a visual way of seeing how these proportions lay out. Notice that what we're doing is we're basically assigning whether it's the short, the long, and the hypotenuse side that we're looking at, and we're making sure that the other side of the proportion follows that same rule, that we're using the same side distinctions. Okay, so now all of that for this. Problems like our last example here. They want us for this problem to separate and redraw and label the triangles, and then set up proportions to solve the variables. So first, let's separate them. Okay, I'm going to give you this one here, the one to the left, which is 4y x. The one to the right, which is y 5, nothing there, and then the original triangle, which is x, and I'll just say this is 9 because that's what it is. Okay, and so now what we are going to have to do is we're going to have to label these as far as like short, long, medium. Okay. I don't necessarily know what this is. I'll call this short. I'll call this hypotenuse. Okay. This is obviously the hypotenuse. This looks like the short side, so that has to be the long. This is the short side. This is the hypotenuse. Okay, so that must mean that this is the long. That must mean that this is the long. All right. And so now what we're going to do from here is we're going to set up proportions to try to find things. Okay, what do I want to find first? Well, I want to find x. Okay, so where is x present? Well, x is present here, where it's the short side and we know the hypotenuse. So I'm going to say, okay, x over 9, short over hypotenuse. I need to find another place where x is present. And notice here that x is present here and it's the hypotenuse. Where's the hypotenuse going in this situation? In the denominator. And so x will be down here. What's the short? 4. Okay. And so here's our proportion that we can use to solve for x. 9 times 4, 36. X times x, x squared. Take the square root. X will have to be 6. Okay, remember the negative answer does not make sense here because it's a distance. It's an actual measurement of something. So x is 6. We can do the same thing for y. Okay. Here we have y as the short side and 5 as the long side. I'll do that over here. So I have y over 5, which remember was short over long. And where else do I see y? Well, I see y here. And y was the long side there. What was the short side in that triangle? 4. So cross multiply, y squared equals 20. Take the square root. And so y will be 2 radical 5. Again, the negative answer doesn't make sense, so we don't have to write it. Okay, so this is using similarity in right triangles, using the strategy of redrawing and relabeling the triangles. Okay, we'll practice with this, and then we'll look at a different way to solve these types of problems. See ya.